Darby Holdings, Archer Division, invented, developed, patented, successfully tested, and deployed into industrial operation the new revolutionary and environmentally safe enhanced oil gas condensate recovery system for recovery of petroleum from low productivity and abandoned oil wells. Our new proprietary and patented thermal pressure technology solves the problems of complete hydrocarbon extraction from capped, abandoned, and low productivity dying wells, such as the orphan wells found in Texas. The productivity and life of depleted wells will be increased dramatically. It is a patented new generation of slow oxidizing, high energy density synthetic mixture of propellants combined with an environmentally safe oxidizing compound. The energy density of this combined mixture exceeds more than 10 times the energy density of any other known chemical explosives. Depending on well structure and ambient bedrock, up to 1,500 liters of treated mixture is pumped into a well. That mixture has the energy equivalent of 15 metric tons of high energy explosives. Chemically ignited, this energy will be released into a well's perforated zone and surrounding bedrock during a 12 to 24-hour period as surges of hot pressure gases of very high temperature. The mixture is certified as an environmentally safe compound with no danger to human health. The oxidizing compound added to high energy propellants activates the slow oxidizing combustion reaction, forming high temperature, high gas pressures, releasing all of the primary active energy accumulated in the mixture and resulting in high temperature, high pressure primary active gas surges. These surges are applied to the producing pipe's perforation zone, to hydrocarbon reservoirs, and to bedrock around the treated well at a distance as far as up to 1,700 feet, drastically increasing porosity and permeability of the bedrock. In addition, the heat and pressure of primary active gases also generate the secondary energy and secondary reactive gases in the productivity reservoir zone and the bedrock around the well. The impact of high temperature, high pressure primary gases formed during the combustion process clears the perforation zone and the reservoir area around the wells from clogging paraffins, asphaltins, resins, clay, and cemented sediments of drilling liquids. It is particularly evident in such wells. The speed of filtering through the perforated zone increases well productivity many times over. This unique technology is applied to wells with oil productive zones from 400 feet to 18,000 feet deep and stimulates the oil and gas deposits as far as 1,700 feet around the pipes to recover up to 98% of the hydrocarbons left in abandoned, capped, and low productivity wells after treatment by our environmentally safe technology. The thickness of the productive oil zone can be from 5 feet up to 600 feet. The productivity of all these wells within 1,700 feet from the treated well increases commensurate to how close to the treated well these wells are located. The treatment is effective for oil fields with any kind of bedrocks, including those with 100% clay layers. The cost of treatment is comparable to the cost of middle-level maintenance work. The technology and propellants composition with combustion and oxidizing environmentally safe liquids are our patented, environmentally certified intellectual property. In order to calculate the exact amount of combined mixture to treat the well, we need the following information from well owners. Geophysical characteristic of oil field and the well structure and specification, depth of the well and location of all reservoir productive layers, complete specification of perforation, holes per meter and their diameter. Filters. History of a well's productivity from start to current liquids and gas extraction per day. Specification of carbohydrates and ambient bedrocks, including porosity and permeability. Specification of underground water, salts, and location of underground water layers. Present static and working pressure. Temperatures. The well's owner will be given detailed checklists of all information requested. The sequence of a well's treatment. Stage 1. Fill the well with water. Move the pump tubing down to the bottom hole of productive perforated zone. Pump in patented propellant solution number 1 with specific gravity, 1.3 grams per cubic centimeter. Keep the annular space open. Stage 2. Lift the pump tubing above 65 feet over the upper holes of perforated zone. Pump into the well the patented oxidizing solution number 2 up to the wellhead level with specific gravity, 1.6 grams per cubic centimeter. Stage 3. Leave the well for 12 hours. Close the annular space and inject the reactive product into the productive zone bed. Move the pumping tubing down into the upper level of the perforation zone. Stage 4. Close the annular space. Pump in the patented solution number 3 into perforated zone bed to neutralize all liquids in the well and to remove the formed colloidal products. Stage 4. Close the annular space. Pump in the patented solution number 3 into perforated zone bed to neutralize all liquids in the well and to remove the formed colloidal liquids. Oxidizing compound added to the high energy propellants activates the slow oxidizing combustion reaction, forming high temperature, high pressure gases for up to 24 hours, releasing all of the primary active energy accumulated in the mixture and forming high temperature up to 270 degrees Celsius and high pressure up to 70 atmospheres of primary active gases applied directly and horizontally to the productive pipe's perforation zone and to the hydrocarbon reservoirs as well as to the bedrock around the well at a distance of up to 1,700 feet around the treated well. The impact of high temperature, high pressure, primary gases formed during combustion process clears the perforation zone and reservoir area around the wells from clogging paraffins, asphaltants, resins, clay, and cemented sediments of drilling liquids. Heat and pressure of active gases generating the secondary energy and secondary reactive gases in the productive reservoir zone and in the bedrock around the well are created as the atomic hydrogen recombines into molecular hydrogen. This is followed by forming carbon monoxide, nitric oxide, hydrochloric, and nitric acids, filtering into the well's reservoir and bedrock with high speed and high pressure surges. This process far exceeds the blasting energy and pressure of any explosives. The mixture of heated gases with atomic molecular hydrogen does not dissolve in oils. In the chemical reaction, the hydrogen goes through a chain of transformations and is the sustaining force of chemical reaction in the reservoir itself, creating additional energy, high temperature, and high pressure surges applied to ambient bedrock around the well. The major thermodynamic potential of compounds is realized in ambient reservoir outside of the well's productive casing, resulting in the following. First, it creates myriads of microgaps in the rock ambient around the well, immensely increasing the porosity and permeability of bedrock ambient in the horizontal direction. Second, molecular hydrogen activates cracking in oil, breaking long carbon chains into short ones. Third, in situ hydrocracking and partial pyrolysis of long chain hydrocarbons with their transformations into shorter carbon benzene and gas fraction, partial cracking. Fourth, as a result, it decreases the density of oil and increases the oil API. Fifth, it creates the short time in situ combustion of tar deposits. Sixth, the selective skin factor is decreased, separating hydrocarbons from surrounding bedrocks. Seventh, it creates the consolidation of loose oil gas reservoirs due to bedrock structure secondary modification. As a result, in the productive oil zone and bedrock around the well, the porosity and permeability are significantly increased, and respectively, the hydrocarbon productivity of treated wells is increased from 5 to 30 times. Also, productive times of wells are increased up to 5 years. Combustion and oxidizing mixtures and their reactive products are ecologically safe, proven by sanitary and epidemiological services, and comply with strict environmental specification. In summary, this game-changing technology is applied to wells with oil field productive zones from 400 feet to 18,000 feet deep and stimulates the oil and gas deposits as far as 1,700 feet around the well's pipe to recover up to 98% of hydrocarbons left in capped and low productivity wells. The thickness of productive oil zone can be from 5 feet up to 600 feet. The productivity of all wells within 1,700 feet from the treated well increases commensurate with how close to the treated well these wells are located. The treatment is effective for oil fields with any kind of bedrocks, including 100% clay layers. The cost of treatment is comparable to the cost of middle-level maintenance work. The technology and propellants composition with combustion and oxidizing environmentally clean liquids is our patented, environmentally safe, and certified intellectual property. Thank you very much for your time and attention.